Thanks for your interest in serving your community as a storm spotter. This training should give you the basic information you need to be able to safely observe storms, to correctly identify key features, and to make high-quality reports. Tornadoes and the cloud features that come before them are the most important things for spotters to be able to identify. Fortunately, the chances you'll have to deal with any of these is very low, but it's important to know what you're looking for. In this section, we're focusing on supercell thunderstorms and that part of the storm where tornadoes are most likely to develop. This is what we call the action area, and it's where the updraft and downdraft come together. In most cases, this will be on the backside of a supercell storm. So if you're dealing with a storm moving from the southwest toward the northeast, the updraft will typically be on the southwest edge of the storm. One of the main visual clues spotters should look for is the wall cloud. The wall cloud is an isolated lowering of the cloud base. As you can see in this side view of a supercell, the wall cloud forms beneath the main updraft and adjacent to the rainy downdraft. Here's a close-up look at the base of a supercell thunderstorm. Once the wall cloud is formed, it may look something like this. Cool, rainy downdraft air, shown by the blue arrows, moves from the downdraft back toward the updraft. If the updraft is powerful enough, some of this rain-cooled air will rise and form small clouds, and these may attach to the updraft, forming the wall cloud. Remember that a wall cloud is always attached to the updraft. Wall clouds take on many shapes and sizes, and what they look like will depend on a lot of factors, including the size of the storm, the humidity, how much instability there is, your distance from the wall cloud, the time of day, and other factors. They're often described as blocky with sharply defined edges, but this is not always the case. Wall clouds can occur in pairs, and if conditions are right for one wall cloud to form, then other nearby updrafts are also likely to form wall clouds, such as the picture in the lower left. So when you're out storm spotting, don't become too focused on one thing. Keep scanning the sky around you for new developments. It's also very important to remember that the wall cloud does not equal a tornado. Lots of storms produce wall clouds, but very few of them go on to produce a tornado. They're important cloud features to watch, but just because you see a wall cloud does not mean a tornado is imminent. There are lots of clouds that can look a lot like a wall cloud, and it can be confusing for spotters to tell the difference between scary-looking clouds and the real thing. If you're having trouble deciding whether it's a wall cloud or not, ask yourself these three questions. Is it connected to the base of the storm? Wall clouds are a lowered part of the cloud base, and they will always be connected. If it's not connected, it may just be scud clouds. Is it in the right part of the storm? Remember, wall clouds usually form in the action area, where the updraft and the downdraft are close together. Is it sloping down toward the rain? Not all wall clouds will do this, but this can be a sign that the cloud you're looking at is associated with a strong updraft and is ingesting cool, rainy air from the downdraft area. If you don't answer yes to all three questions, it's probably not a wall cloud, but things can change quickly, so you might want to keep an eye on it to see how it changes over time. Clouds are always moving in and around thunderstorms, and spotters can use that cloud motion to help them know what's going on with the storm. Most of the time, moving clouds aren't anything to be concerned about, but when the clouds are rotating, it can be important. Rotation is defined as organized, sustained, focused cloud motion around a vertical axis. In this diagram, the cylinder represents the cloud we're watching. Rotation would be cloud motion like a merry-go-round in a circle around the imaginary pole running through the middle of the cloud. This motion would be focused around this axis and persistent for several minutes. If you see clouds moving, but they're not focused around a vertical axis like this, then it's not rotation. Remember that although wall clouds are important, they don't mean a tornado is guaranteed to happen. Many storms produce wall clouds, and nearly all supercells produce wall clouds, but very few storms ever produce a tornado. As a storm spotter, your key is to be patient and observant, and monitor the wall cloud for changes over time. These are some of the signs that a wall cloud could be about to produce a tornado. Persistence for 5 to 10 minutes or more. inflow winds that are increasing toward the storm, the lowering of the wall cloud toward the ground, increasing rotation in the wall cloud, and an increase in rapid upward motion in and around the cloud. If the wall cloud displays one or more of these signs, the storm may be very close to producing a tornado. Again, the key is to watch how the cloud changes over time. Is the rotation getting stronger? Is the cloud base getting lower? A report describing these kinds of trends are usually more useful than one just saying, "The sky can seem full of things that look like funnel clouds when there are storms going on, but funnel clouds don't really happen that often." If there's a funnel cloud, we need to know about it, but it's important to be fairly confident that you're really looking at a funnel cloud. Here are some key things to look for to determine if it's really a funnel cloud. Is it rotating? The rotation may be very difficult to see depending on the lighting and the storm location. How persistent is the funnel cloud? Is it persistent, and how is it changing over time? Even if you can't see definite rotation, a persistent funnel-shaped cloud in the right part of the storm is something that should be reported. Also watch for trends to see if the funnel is lowering toward the ground or if rotation is increasing. Remember to describe only what you see without trying to predict what may be happening minutes from now. Surely you've seen many pictures and videos of tornadoes. The definition of a tornado is a violently rotating column of air in contact with the ground and extending down from a thunderstorm cloud. Just like wall clouds, tornadoes can appear in many different shapes and sizes and even different colors. We hope you understand that your job as a storm spotter is not to find a tornado. Chances are you'll never even see a tornado. You are not a tornado spotter or a tornado hunter. Your job is to report what you see. There are two things that make a tornado visible. There is a condensation funnel, which extends down from the storm, and there is dust and debris kicked up from the ground. It is not necessary for the condensation funnel to extend all the way to the ground. Sometimes your first clue that a tornado has formed is a swirl of dust and debris at the surface. If you see this, look above the swirl to see if it's associated with a funnel cloud or visible rotation on the underside of the thunderstorm. This is called cloud base rotation. If a funnel or cloud base rotation accompanies swirling debris on the ground, then you're likely looking at a tornado. Obviously, it's important to report a tornado if you see one, but it can be just as important to not report something as a tornado unless you're somewhat confident about it. A tornado is connected to the base of the thunderstorm and is in contact with the ground. Ask yourself these questions when you're trying to determine whether the cloud you're observing is a tornado. Can you see it clearly? Is it attached to the base of the storm? Is it in a spot where you'd expect the tornado to form, near the updraft area? Do you see organized rotation in the cloud? If it appears to be a tornado, can you see any evidence of dust or debris on the ground underneath it? If you answer no to any of these questions, then what you're looking at is probably not a tornado. Keep watching it though, because things can change quickly. In this example, we can't really tell for sure what's going on at the ground level because there are trees blocking our view. So your report should describe just that. With the trees out of the way, we can see evidence that the tornado circulation is on the ground. But in the real world, you don't know that. Remember, report only what you see, not what you think you see. For more details about wall clouds and tornadoes, check the Weather Spotter's Field Guide available at this address.